Now let's use what we've just talked about to answer kind of a neat question. Did you ever notice when you unplug something? I notice it with my iron all the time, sometimes with my computer, sometimes with my toaster oven at work. Did you ever notice that when you unplug it, you get a spark? So what we've covered explains why that happens. Your potential difference, delta V, can be really big if your current changes pretty fast when you do something like flip a switch or if you unplug something. So what if we go from a circuit with a closed switch to an open switch? For example, something is plugged in and we unplug it. That's the same thing as opening a switch. Well, what happens when the switch is closed, the current is going through the circuit, and let's imagine our circuit is just our potential source and the object that we have, which is like an inductor. So let's imagine that's what we have. The current goes really fast from a current that's big to a current that's zero. If we unplug it, if we break the switch, then we go to a zero current all of a sudden. The current change is very big because it goes from a big current to zero. The current itself is going to be big because our inductor has no resistance. So the only resistance in the entire circuit is due to the internal resistance of the battery. So the current itself is big, which means the change in current is also big. It goes from that big current to nothing. If we unplug something, that doesn't take us very long. So our delta T, our change in time, is small. So overall, our change in potential, delta V, or our induced EMF, is very big. We have a big change in current divided by a small time. So we get a big potential across our inductor. That potential is also going to be across the gap in the circuit. So there's a small opening between your plug and the wall where you're pulling it out. That's a small distance that has a very big potential. You get a dielectric breakdown in the air. So if that potential over that distance, delta V over delta D, if that's bigger than about 3 million volts per meter, then you get a spark, just like lightning. So that's kind of neat. And for what it's worth, this is also how spark plugs work in cars, although I'm not really very mechanical, so I don't do a lot of automotive examples. So that's kind of an interesting application of what we've just been discussing.